Okay, today we are going to attempt to process some astrophotography based on raw data from the James Webb Space Telescope. So we're going to go to the MAST archive of the Space Telescope Science Institute. MAST. You can search using this, but it's better just to go to the advanced search. Now, this is all the telescopes that are managed by the Space Telescope Science Institute. And we want to search by project, James Webb Space Telescope. And this is everything that they've released, but we're only interested in the stuff that was released after a certain date. So we actually have to turn on the release date on the left. So we're going to check that. I'm going to scroll this all the way over to right about the present day. And then it just makes it easier to change it to, let's just go back to the first and see what we get. 5,000 records. That's a bit too much still. I like to get that number down to a couple hundred. So we're actually going to go to data rights and turn that on. And we only want the public stuff. That's going to bring it down to 200. So now we have a good subset of data, public data from the James Webb Space Telescope that was released after August 1st. And it's a small number. So we'll hit search. And then, the first thing I do is just check the target names. So we got the Cartwheel Galaxy NGC 5139. What is that, right? That is the Omega Centauri globular cluster. I took a look at that data earlier. It's all uncalibrated data. It's not good to work with. What you want is the I2D files. We'll get to that in just a second, but if we look at the Cartwheel, we can see there's MIRI data, NIRChem data, and NIRSpec data. We don't want the spectroscopy data, so we're going to just check these two. We've got 4 filters from MIRI and 6 filters from NIRChem, and we can work with all that data. So let's check all of them. We could download them all individually by saving them, but I like to add them to the basket. And then we want the I2D files. JWST Science Products. Let's see if this is it. Science Products. We want these. We want the I2D. They're images that are two-dimensional. 2D images, I2D, so we want those. The way we're going to do that is by, once we get these in our basket, then we can, so those are FITS files. That's the type of file we want. We don't care about all this text, just want the FITS. And then if we look at one of them, we're going to see an I2D, two-dimensional image, and then we have a segmentation file, which you can read about here, segmentation map. We're actually not interested in that. We could uncheck them all. We could expand every single one of them and uncheck them, or we could download them all, but we don't need them. So they're actually all auxiliary. We don't want those. We want just the science. So now we have the 10 files that we want, 6 from NIRChem and 4 from MIRI. So now we're going to select all those and we're going to download them. It's going to save it as a zip file. And that's the first part. This is a 2.34 gig file. This is the raw data. And then in the next section, we're going to talk about how to view the raw data in such a way to save it or export it as a TIFF file with the best quality. So we'll look forward to that in the next section. As a disclaimer, I'm an amateur. I have no idea what I'm doing. Any images you create with this process are to be considered unofficial and just hobby images. So when this is done, we'll start up the next session. See you. This is Jason Rubik.